All right, so hopefully those videos helped you to get a new appreciation for the strength of atmospheric pressure as it pushes down and pushes on us. Next thing in your notes, and this is a term I believe you've had already in your note, the term fluids. I think we've got that in our notes once before. Fluids is a term that refers to both liquids and gases because they have no definite shape. Basically, just get down that fluids are both gases and liquids and gases. And because liquids and gases have the no definite shape, they're both able to flow, hence the name fluid, flowable. There are some principles that we talked about in last chapter. We're going to look at these more tomorrow as well. But there are some principles that apply equally to gases as they did to liquids. Now, Pascal's principle does not apply, right? A liquid has a definite volume. It is mostly incompressible, and an ideal liquid certainly is incompressible. So when you push down on one end of the hydraulic jack, the liquid is forced. The liquid doesn't just squish, right? But you know, air can largely be compressed. So Pascal's principle doesn't apply. The principle of continuity holds true because a certain volume of liquid has to flow through a chamber. So as the liquid narrows down, as the chamber narrows down, it has to speed up. Well, gas will just compress down without a problem. Without too much of a problem. So while gases may speed up a little bit as they're passed through a narrower opening, you don't see the same kind of relationship there. But there are a couple principles that do still apply. One of them is Archimedes' principle. Archimedes' principle, remember, says that in a liquid, an object experiences a buoyant force, a lifting force, an upward force equal to the weight of displaced liquid. We said this is even true for the gas, right? We said there's a gas lifting up, pushing up with a buoyant force, if you will. We don't really call it that for a liquid, but there's force lifting upward that counters the force pushing downward, right? Well, this doesn't displace a whole lot of air, correct? So it weighs more than the air it displaces, since it displaces virtually nothing. So obviously it falls. But if you could get something that displaces more air than it itself weighs, again, you would get floating action. So we're just like we said for a liquid. The key to something floating a liquid is the object's density would have to be less than the density of the liquid it is in. Usually we tend to think of the density of water, right? Well, in this case, to get something to float in air, we have to get something that has a density that is less than the density of air. Well, there are a couple of gases you looked at last year in chemistry that have a density less than that of air. What they are?
Helium.
Helium, certainly, right? That's the most common balloon, right? You blow air into a balloon, right? And it sort of floats downward, right? It's not pulled down hard by gravity because air outside pushing up and down and all around, air inside. But you still have the weight of the balloon itself, and the air you're breathing out, carbon dioxide, is a little heavier than the air around us, or more dense than the air around us, so that balloon would sink. But if you can fill a balloon with helium, right, it goes up. And if you ever lost a helium balloon unintentionally, it's a traumatic day as a small child, right? You're playing with your balloon, and flies away, and you start crying, and parents never understand, do they? That was your prized possession. You know, Dad just doesn't get it. It's like, Dad, how would you like if your wallet started floating away? Get back here! You know, that's how I feel right now. Dad, my balloon. There we go. Crying. And, you know, crying also because you know it's going to kill some sea turtle or something. Tears and sadness. But helium, right? It's less dense than the other air around it, so helium rises up. There's another one that I wouldn't recommend trying to use in a hot air balloon. The least dense of all. Hydrogen. Why not hydrogen balloons? Wouldn't they float better than helium balloons? They would, but highly flammable, right? And you think back to the Hindenburg explosion. Remember learning about that in history class? Yeah, smart people are like, hey, hydrogen's the least dense. Let's fill a whole big balloon full of hydrogen. Let's send it on its merry way. And it worked great until it didn't. You remember what happened?
Exploded.
Yeah, why? Do you remember? One of the tow lines when the balloon was coming in, where the lines dragged across the ground, it got just a little spark. boom, everything goes up, and it's a bad day, and they realize maybe hydrogen wasn't the best idea. But hydrogen balloons, I think if you look on YouTube, you can find videos of people blowing up hydrogen balloons at like Lowe's or Home Depot or someplace like that. Why, I don't know. At least it looks like it was a place like that. They were filling a balloon with hydrogen, and then poof, and it ignites and explodes. It's great fun. But there's another type of balloon that has been used even throughout the ages, even to this day, more for recreation than for transportation. Hot air balloons. Remember we said hot air, as you change the temperature of air, you change the air pressure, right? You increase the pressure because the molecules start moving faster, so they can cause the balloon to expand without adding additional molecules. So we're not adding any more weight to the balloon, but we're still causing the balloon to take up more space. It's displacing more air. It's displacing a greater weight of air, kind of like the life jacket. In displacing more water, Chloe floats. Displace more air, hot air balloon begins to rise. That's why hot air rises. It's less dense. As the air molecules spread out, it's less dense than the air around it. And so the balloon goes up, and people still use hot air balloons every now and then. Today, most recent example I can think of was that guy from the Raiders who decided to fly into camp on a hot air balloon just because he wanted to do something splashy. He was an idiot. He did all kinds of dumb things and got himself kicked out of football a few different times. But anyway, I digress. Homework for this evening. I need you to read over pages 49. Read over pages 49 to 57. Read pages 49 to 57. And I'm not sure how I didn't have this written down. On page 67, I need you to answer questions 1 through 12. Questions 1 through 12. So page 67, questions 1 through 12. We'll take a look at all of that in our next lesson, but I got to let you go a little bit early. You got snack cart or pizza day to set up for. So have a wonderful rest of your day.